Good morning, everyone. So we are just waiting for the other participants to trickle in. And, Right, so we have come to plenary 3 on day 2. So I'd like to invite my co-chair, Professor Asita, to introduce the speaker.
Thanks, Chiranti. It's always a great pleasure to introduce a fellow clinical pharmacologist from a very vibrant department, the last bastion, as it were, in the UK, or one of the last bastions. Lauren Walker. Dr. Lauren Walker is in clinical pharmacology. She's a reader in clinical pharmacology and therapeutics, honorary consultant. She was introduced at the last symposium, so I won't take much time introducing you to her. She's interested in predicting risk and examining patient journeys to identify at what point harm of a medicine outweighs the potential benefit. I was talking to her during the tea break and learned that she's starting work on human challenge models in research. That's the next level of clinical trials. It's a hugely advancing area, exciting area with many advances in recent times. And I was really thrilled to learn that Liverpool is starting that kind of work, because I have some friends and colleagues I work with in Liverpool. So Lauren, thank you very much for being here. And we'd like to invite her to talk about application of artificial intelligence in medication safety. Thank you, Lauren.
Thank you. Should I wait for the music to stop? Or I don't know whether, should I talk over the music?
That's part of the artificial intelligence.
So it's wonderful to have the opportunity to speak to you all again about a different aspect of the work that I do, but that I increasingly get asked to talk about actually, which is the use of artificial intelligence for medication safety, largely because this is going to be a challenge for us in the future. In that when I went to medical school, there was no talk about AI and data science, and I wasn't trained to interpret AI algorithms and how I might use them to predict risk in individuals. And as a consequence, we often talk about the black box nature of AI, that we don't understand the algorithms that underpin it, the machine learning architecture that underpins it, and therefore we are going to be asked in the future as clinicians to make decisions about patients based on computer algorithms that we don't really understand. And that's an enormously challenging thing to accept, I think, as a clinician. So there's two aspects that I'm going to focus on. One is prognosis prediction and the other is risk stratification. There's all manner of different ways that you can apply AI to decision making, but I'm going to choose these two, and we'll try and do a bit of a deep dive. So essentially, let's start from the patient perspective. This is the kind of what I would call from cradle to grave trajectory that all of us will go through if we're fortunate enough to live a long life. And as we age, we accumulate more long-term conditions. And the longer you live, the more you're likely to acquire, because age is the single biggest risk factor for long-term health conditions. And there is a balance for all of us between the medicines that we take to treat symptoms of the conditions we have versus the medicines that we take to either manage the disease or prevent subsequent diseases. And in the case I showed you earlier, Marjorie, a lot of the bulk of her medicines were for the prevention of subsequent disease. But there will come a point in our lives, in all of our lives, where the decision should be made to prioritise symptom management over further disease prevention if we're ever going to tackle the problem of overprescribing. But at the moment, it's very challenging to determine where in the trajectory the best point to intervene is. So if you look at all the red stars, that's where you start to get hospitalised towards the end of life. And I would argue that we should target medicines optimisation at the start of those red stars to try to prevent medicines-related hospitalisation, which in the UK accounts for about 16.5% of admissions. So to try to prevent that, that's where we should target. Unfortunately, though, what we're having to do is target medicines reviews right at the end of the trajectory where that's what we're trying to focus on. And so there's this whole couple of years in between times where people spend a lot of time hospitalised. So that's one aspect in which we can use existing health data to answer that question. That relies on us having a good data architecture or infrastructure. So there has been a huge digital transformation in health in high-income settings like the UK. So the electronic health record we've been using for many years, we probably have data on around 40 million people going back about 15 years. It comes from 704 NHS hospitals and 6,495 community sort of general practice centres in the UK. So that feeds into what's called the integrated care record, primary and secondary care. But there's lots of other sources of data. So there's social services data, there is death registries, cancer registries, all manner of different data sets that can feed into the electronic health record. And then we can take a research version of that. So in the UK, that's the CPRD, the Clinical Practice Research Data Link, which is basically every month a download of all the information that's contained within the primary and secondary care record. And importantly, it is irreversibly de-anonymised. So CPRD is a research copy of the electronic health record with all of the identifiable information removed, and it can never be re-identified. So it's wonderful for research purposes. If we want to deploy AI algorithms to understand or predict risk, that's great. But what it can't do is allow me to re-identify those patients in my hospital in order to be able to perform a medicines review. So that's at the moment, one of the barriers, and we'll talk more about that later. It also only incorporates structured clinical data. So that means coded data. So diseases have codes, medicines have codes. That's what it contains. It doesn't take the unstructured narrative, which is about 80% of the health record information. So unstructured narrative, it's the bit where you say, so the structured data will be the code for warfarin. The unstructured data might be, I've advised this patient to take 2 milligrams one day, 1 milligram the other day. All you'll get with coded data are 1 milligram tablets. And that's the difference. So there is a lot of the nuances lost about why we make prescribing decisions. There are also some silos. So I'm a medical advisor for the HIV drug interactions website. And so I do a lot of work around HIV drug interactions. So sexual health data is not contained within the research data set. Psychiatric records are not either. And then some of the most vulnerable among us, so prisoners, homelessness, asylum seekers, none of that data feeds into the research data set. And that's important when it comes to representativeness, and we'll talk about that soon. And we heard this morning about how the cornerstone of evidence-based medicine comes from the randomised controlled trial. And RCTs are the linchpin of telling us whether a drug can work. You know, does this drug work for the indication for which it was prescribed? And RCTs receive a lot of criticism around not being representative of people with multimorbidity or not being representative of the very elderly. And the counter-argument is that people will say, well, why don't we put people with multimorbidity into RCTs? But the challenge is that a randomised controlled trial is meant to be an unbiased estimate of effectiveness. So if you then start to include lots and lots of people with varying different complexity of multimorbidity, you will lose some of that. So one way to supplement the RCT and answer the question, will this drug work in the patient in front of me, is to use observational data as well. So once that drug then gets licensed and it's used in the real world, what you can do is follow it forward or emulate it within an observational study. So using that CPRD data set to follow forward certain patients and to supplement the information. And the argument being that you use the larger numbers in an observational trial to overcome some of the bias around observational data. So I think we'll see more of that in the future. That's one of the benefits. So that's just a bit of a background setting to AI. So my interest is in drug-drug and drug-disease interactions. So what combination of drugs and diseases it leads to the greatest risk of harm to an individual. And one application for AI here is to use something called SPADE, which is a machine learning algorithm. So machine learning is the instructions that you give a computer in order to achieve AI. So AI is the decision making, machine learning is the architecture. So SPADE is sequential pattern discovery using equivalence classes. And the best way to sort of give you an example is something like this. So this is the Danish Disease Trajectory Browser. It's a wonderful integrated data set. And it's free to use, anybody can have a go. So I picked a disease I was interested in. So the green dot in the middle there is schizophrenia. So this uses a traditional statistical pairwise approach. So if diseases commonly co-occur together in a pair, A leading to B, then that forms a node. Multiple pairs that occur in sequence can then be sandwiched together. So this is not machine learning, but I'm using it as an example of how you could extend this if you applied machine learning to it. So this tells you about what conditions occurred before schizophrenia. So the green dot is depressive episode, and then there's lots of other conditions before that. But you can also track it if you're interested in, well, what happens to people who get a diagnosis of schizophrenia and then die, which is the pale green at the end, and it will break it down and show you what are the common things that happen to people. So it's very useful for understanding trajectories. But what you could do is, if you apply a SPADE algorithm to this, is understand not just the diseases, but where the drugs come in. So what are the common sequence of diseases and drugs that lead to harm, and you can adjust for whatever harm you're interested in. And the reason I think that's useful is if you want to build that then into the electronic health record, you can develop a system that will then prompt you to screen for certain things. You know, so in my own interest for HIV, for example, if you could find what pattern of clinical encounters or circumstances led to a diagnosis of a blood-borne virus, for example, then if a patient acquires that combination, then it will flag to the clinician, you should screen for blood-borne viruses here, or you should screen for hypertension here, or check for diabetes, because I have learnt as an algorithm that this sequence of events led to harm in X number of people. So that's one potential application. And how it does that, it's always difficult, challenging around explaining AI. So it's called association analysis. So you're looking for frequent item co-location. So if you look at, this is baskets within a standard supermarket. So I've given you 5 baskets there that contain very similar items. So you can see that diapers and beer is a similar or a frequent item set. It means that people put those 2 items in their basket commonly. And there are 2 types of machine learning approach. You can either use supervised or unsupervised learning. So a supervised learning means you tell the algorithm, you tell the computer in advance, this is beer and this is diapers. Or you can do, and then find me beer, find me the things, the patterns that have those items in. Or you can just give it all of the items unsupervised, so you don't label them, and you say, find me the similarities between all of these data sets. Find me the things that look alike. And then it will put beer and diaper together. I'm being glib because I'm using a supermarket example, but if you then apply that to drug discovery, for example, to finding new medicines or discovering disease patterns, you can see how you could then provide it with structural information for a medicine and ask it to find me the things that are similar. Or tell it about an unsafe drug interaction and ask it to find the things that are similar or will predict that uncertainty. We've gone one step further with this recently, because if you think about in a supermarket, so SPADE algorithms you will have seen if you've ever watched any show on Netflix, for example, it's what Netflix does when it predicts what other shows you might like. If you've ever bought anything from Amazon, it's what Amazon does when it says, people who bought this also bought this, would you like to buy it? The order in which you buy things or watch things doesn't matter in those algorithms, but it does matter in human health. Whether you have diabetes first and then go on to develop a heart attack versus having a heart attack, gaining a lot of weight because you can't exercise and then developing diabetes. Those 2 outcomes for that individual could be quite different. So the order of acquisition of events matters. So we extended the SPADE algorithm to apply a timestamp. So this is looking not just for frequent item sets, but the order, frequent item sets that follow a particular order. So it's the same, the table is, imagine the table is now your basket. So that's 5 different patients instead of 5 different baskets. And you can see that they've got commonly, very common conditions. 3 of the individuals have diabetes as their first disease. Of those 3, 2 go on to develop chronic pain as their second disease. So you build something called an enumeration tree, which is this over here. So each disease gets its own root on the tree. So diabetes has a root. In 2 cases, the first branch after diabetes is chronic pain. In 1 case, the first branch is liver disease. So if you imagine you now throw 40 million patients worth of data over the last 10 years into an algorithm like this, in minutes, this machine algorithm can tell you what are the most commonly occurring branches on that tree, which is not something that you can do with a traditional statistical approach or something that the human brain can do quickly and easily, but it is something. So thinking back to that Danish disease trajectory browser, this is the kind of thing that this sort of algorithm can do that's very difficult for us to do manually. And then you ask it, well, I'm interested in this particular risk, this particular outcome. What are the most common branches on that tree that lead to that risk? So, and that's how you apply it to diseases. You might also choose to apply it to surfacing medicines risks. So I spoke earlier about how it can be difficult to find within an 18-drug list for an individual those that are causing the most harm. And I know that a lot of these medicines have an associated anticholinergic burden, and that gets worse the older you get because of the physiological changes that happen as we age. So the loss of kidney function, shrinking of your liver, reduction of the blood flow, change in your kind of skeletal muscle mass, all those kinds of things. We don't know yet what is the point in an individual's trajectory where the physiological changes mean that they're getting a lot of the harm from their medicines rather than the benefit. So one way that we could then look at these prescribing trajectories using those algorithms could help us to answer that question. Okay, so we're going to take a slight detour now. So that's thinking about trajectory. My big interest, I suppose it's obvious now, is in around how things evolve over time. So the trajectory of an individual. So we'll move away from that, and we're going to talk a little bit about drug safety information using natural language processing and generative AI, which is the chatbot ChatGPT, is underpinned by GPT-4, which is a generative AI algorithm. In order to help us automate drug information. And I'm going to use the example, this is going to be very focused on antiviral medicines for HIV, but you can apply the same principle to any other medicine safety issue. So one of the challenges that we have in HIV care is around multi-way drug interactions. So there's lots of different resources that we use when we're prescribing to look at drug-drug interactions. So I've shown you on the left, that's a snapshot of the HIVdruginteractions.org website. So for silo-based prescribers, so prescribers of antiviral drugs, they will use that to check against co-medication. So they put their HIV drugs in, and then they put all the other medicines that an individual is taking. And that will pinpoint the 2 medicines, so metformin and atenolol, that have a potential interaction with the HIV drug. The challenge, of course, for everyone else is all the co-medications, co-med to co-med, might also interact. So that then requires you to open a different interaction software. So we use the British National Formulary one. I put all the co-medications in, and then I come up with 27 potential interactions between those drugs. And at least 2 of those have a potentially serious clinical consequence. What we don't know, because it's complicated, is in somebody that takes 18 different drugs, for example, does the interaction between drug A and B, which increases drug B, is that counteracted by drug C that also influences B and reduces its level? And it's that complexity of different interactions we don't know the clinical consequences for. And I think that's a really useful use for AI for the future. So we've been using a model based on this paper. And hold on to your hats for the kind of the underpinning AI architecture, because some of it is a bit challenging, but I'll try to explain. So this was a study published in MPJ Digital Medicine a couple of years ago, and we've been trying to extend it since then. So they extracted reliable drug information from the FDA drug labels. So, and I use the term reliable information deliberately, because any AI algorithm that you're going to develop will only be as good as the data that was used to train the model. So you have to be really confident of the data that has been used. I often get asked, why can't we just run ChatGPT on our electronic health record and get it to learn all of these patterns? Why do you do what you do? Why don't we just use the tool that's already there? But there is so much variability in that data resource that we have to develop individual algorithms that meet the needs of the particular question that we're asking, and that's really important. So using the FDA drug labels, because that contains the clinical drug interaction study information, they built their own version of a what's called a regression-based tree model. So it's based on bootstrap aggregation. So similar to the enumeration tree that I showed you before. But they're looking for, essentially, the victim and the perpetrator drugs. So they scrape all the information and they look for victim and perpetrator. And I'll show you how that's done. So we're taking a lot more data resources. So they're just looking at drug labels, but we've scraped all the drug labels, the FDA and the European drug labels. We're taking the drug bank, scrape the information from drug bank, which will tell you all about the protein interactions and things. The British National Formulary, so we're using their drug interaction information, and then our own HIV drug interactions website, so 25 years worth of clinically curated DDI information. And then, so you have to pull all that resource together, clean the data, remove all the duplicates, things like that, look for the drug names, look for which drug is the victim of the interaction and which is the perpetrator, and look for directionality. And only once you've got to that point can you then go about developing your model or getting your model to learn. So, for example, this is the text taken from the Electronic Medicines Compendium for the drug abacavir. And so what you can see is if you scrape, it's called data mining, so that's part of one of the things that you have to do to achieve AI. If you scrape the information for abacavir, that's just one paragraph of information. You ask the algorithm to extract all the drug names within that paragraph. So you can see it's taking abacavir multiple times, methadone, ethanol. So it will pull out all of those things, and then you ask it. So that's Python, so that's the coding software. You basically program it to, every time you find a drug or you find anything to do with exposure, so area under the curve, Cmin, Cmax, you give it all the parameters and you say, so instead of having thousands and thousands and thousands of pages to read, it will snip out 100 characters before and after everything that you ask it to do, and then it automatically populates a table with that information. So that's the first step. So you can see by asking it to look for area under the curve from that just small paragraph, it snipped out that, and it's taken area under the curve and the percentage value in doing so. Then you ask it to look for directionality. So is it increasing or decreasing? So whenever it finds a numerical value, you want it to search for the direction. Does it cause it to go up? Does it cause it to go down? And then it will pre-populate a table. And this is making it look really, there are thousands and thousands of tables. It's an enormous repository of data, but it's still smaller than all the data that's available online. So you can see I've highlighted just a couple of examples. So abacavir and ethanol, so it's correctly identified that the major issue is abacavir, and it's increased the area under the curve or the exposure by 41%. Because ultimately, what you want to get to is this kind of thing. So you need to build those data tables to then train the machine learning algorithm to look for commonly occurring patterns, what happens. And then the predicting of the unknown is the generative AI part. So what you want to be able to guide people to is something like this at the end. So you want to be able to say, not just that there is an interaction between fluconazole and tacrolimus, this fold change in the area under the curve. So you're not just saying there is an interaction, use with caution. You're saying there is an interaction. This is how severe that interaction is, and you need to adjust by X percentage in order to adapt for that. And if there are other drugs that are influencing it, how you might dose adjust accurately for those. And then importantly, what the recommended alternative drug pairs are. So you can ask, one of the things that a machine learning algorithm can do is look for combinations where there wasn't harm that are structurally similar and give you recommendations for alternatives. So that's one of the applications that we're trying to get to at the moment, but it's a long process, but that's in progress. And so So to just then talk about learning health systems, which is something that I feel passionately about, that you can, surely the goal of doing any of this stuff, developing prescribing support systems that can give you accurate dosing information, finding patient trajectories that are at high risk of harm, surely has to be that you have to then be able to identify the patients who will benefit the most. And that's one of our challenges with the research data sets that are being used. And it's not a criticism. I've got lots of colleagues that do lots of big data studies. But the challenge at the moment is if you can't re-identify those patients, then I could talk all day about what harmful combinations of diseases there are. Being able to find the patients is the challenge. So what we're working on at the moment is all the governance around being able to develop this. So what you want is a what's called a secure data environment. So you give access to the research anonymized version of the data to data scientists who are very good at deploying these kind of Python-based algorithms in the data to find which is the commonest combination that is harmful. And then on the other side of the firewall, you would have clinicians, pharmacists, nurses, practice managers within the NHS setting who can then deploy those, get the results of those algorithms, basically, re-identify the individuals to then be able to call those people in for medicines review. So that's what I'm working on. I co-lead a project called Dynamics, which is dynamic AI for prescribing, which does that. So we have 3 key focus groups: frailty, complicated people with multimorbidity and polypharmacy, and then in particular people with serious mental illness and physical health problems, where we're looking at the combinations of harm, extracting and analysing those insights. That's the data science side of the team. And then the clinical work that I do is I then deploy. They tell me who, based on the algorithms, are the most at-risk individuals who would benefit the most, and then I do the medicines optimization for those people. So we're producing things like this, which are called practice-level dashboards. So I couldn't show you real data. So what it will do is it will tell you what are how many patients have you got within an individual practice who have this harmful combination, whatever that might be. Or you can do it on an individual NHS patient. You can say the top 10 patients at risk in your practice today are these, and these are the parameters. The algorithm says that these are the things that put them at that high risk, so you should bring them in. And the reason that we're trying to do this is I'm not a believer that everybody that's high risk of medicines harm is the exact same person who will benefit the most. Those two lists are not always synonymous. A lot of the people who are at very high risk of harm will remain at high risk of harm. There isn't anything that I can do. There are some medicines I can't change. Whereas there are another group of people who are at risk of harm, perhaps not the same magnitude, but they're at risk of harm unnecessarily because the drugs they take are inappropriate. And those are the people in whom I should be intervening. So that is a complicated difference, but that's the work that we're focusing on. To eventually get to these kinds of visualizations, so alongside the case-finding tool, we're developing these sorts of dashboards. These are automated, so this is pulling out the information that's relevant to you from the clinical record without you having to spend an hour preparing for a medicines review trying to find all this information. So, for example, in somebody with hypertension, because all the consultations for hypertension are time-stamped, so all that information is there, so it will pull out, these are all the visits for hypertension, these are the drugs for hypertension, this is how they were changed, this is the impact, so when they were changed, and that could be that it's getting information from a wearable device at home or in the clinical setting. So this is your response to that, your dose-response relationship, and then you can select which other parameters are also of interest to you. So for somebody on an ACE inhibitor, I'd want to track their renal function as well. So all within one screen, it will automate that. Then it will change that. It will also incorporate the guidance information. So if you then develop diabetes, the guidance changes for your blood pressure targets. So it will then auto-populate with that. It will automatically calculate risk scores based on the information in the record for you. And the things that then we're working on at the moment or trying to co-develop is how do you then develop patient-facing tools that allow you to explain really complicated aspects of risk to individuals. So we're doing some work at the moment about how you would develop those. And then if the patient then goes on to develop over time, because I'm a big believer that medicines optimization should be a sequential process because people change. So if they then develop conditions that massively change their risk, just because they were on an antiplatelet before and you thought it was inappropriate and you stopped it, it needs to then tell you actually now they should be on it. This is the things that change. And so I just want to spend the last couple of minutes of this whistle-stop tour on some of the ethical challenges relating to large language models in response to this question that I do get asked a lot about, why can't we just use ChatGPT? People use large language models for all sorts of discovery, and we have this enormous repository of electronic health data. But I genuinely believe our electronic health record data, certainly in the UK, is our oil. You have to protect something that is an incredibly valuable resource, and it belongs to the people that created it, and that is to the patients that input their data into it. And so there shouldn't be an individual that is able to sell it. We need to make sure that the insights that we get from it benefit us and everyone around the world. One of the challenges around deploying ChatGPT, that kind of established algorithm, in an electronic data set is the vulnerability, what they call extraction attack, and that has been proven. So large language models that are trained on a data set can be taught to recover the information. So if it was trained on a data where there were identifiable variables in it, even if you strip all that away, it can still recreate them. It kind of hallucinates them, and it will recreate addresses, names, email addresses, all manner of different things based on what it had learned to do before. So there is a genuine safety and privacy concern to deploying those kinds of algorithms on real-world data. Representativeness, just to go back to what I said before about, if the data set doesn't contain you, can it then truly reflect you? And there are concerns around having some data being considered too private to be part of the care record. I don't really believe in. I think if you have a safe data haven, then it's safe, and it's either safe for everyone or it isn't safe, and we shouldn't be using it. There shouldn't be this halfway house of saying, well, I think it's safe, but I'm not putting the psychiatry record in because it might not be quite safe enough for that. That doesn't, to me, make ethical sense. And so there have been these emulation trials, which I think are fantastic. So LEADER was looking at liraglutide and its action in diabetes and cardiovascular disease, a fantastic trial. It was emulated. It didn't include the oldest old. It generally, as I said before, randomized controlled trials don't generally. So they used the same inclusion and exclusion criteria, but applied just to the electronic data, a real-world data source, and showed that it's still effective in kind of an older age group. And you could do that for all sorts of different drugs. And I think that's a really useful way of proving that a drug works outside of the RCT setting. But you need to make sure that that data source includes everybody, because otherwise you can't say for certain that it works in everybody. And lastly, just about fairness, really, that we must be mindful with electronic data about the inverse care law, that AI algorithms do not apply a conscience. So if something existed and it was discriminatory, it will persist that discrimination. And so one of the examples, different to the one that's on there, but that I would say is in the US, they deployed an AI algorithm to overbook outpatient appointments because they were worried about people not turning up for their appointment. So what's the thing that makes you most likely to not turn up to an appointment, and we'll double book that one, and then there's no empty appointments and no wasted clinician time. The challenge is, of course, that the people who have the greatest need of those outpatient appointments are often come from impoverished backgrounds, and they have lots of social challenges, which means it makes it difficult for them to come to outpatient appointments. So essentially the algorithm deprioritized all those people, and the wealthier people with good access to transport and things like that all got their long appointments, and everybody that was poor got a short appointment that they're to share. So we just need to be mindful of that. Sorry, I ran over slightly there. Thanks very much for your attention.
Thank you very much, Lauren. And since this is a plenary, I don't think that we'll be able to entertain any questions, but thank you very much for that interesting talk and breaking down very complex concepts into little chunks that everybody can understand, and such a comprehensive talk. Thank you very much. And I'd like to thank my co-chair as well for being an absolutely entertaining co-chair during this session as well. And we can move on to the next panel discussion. Thank you
very much, Lauren. I was blown away. I'm a person who gets scared when Netflix asks you, you watch Narcos, would you like to watch Queen of the South? I said, oh, no, I have to take a minute here. Thank you.
Next, we have our second panel discussion on the topic of sharing country experiences in medication safety activities, chaired by Professor Chamari Veeraratne, Professor in Pharmacology, University of Colombo, and Dr. Sujivani Kurukulasurya, Senior Lecturer in Pharmacology, University of Kelaniya.
A very good morning to all of you, and welcome to this panel discussion on sharing country experiences in medication safety activities. And we have with us today 7 eminent panelists from overseas as well as from Sri Lanka. We have panelists from the United Kingdom, and then Australia, Switzerland, India, and also 3 panelists from Sri Lanka. And so this is going to be an interesting session looking at the medication safety related activities that are happening in several countries of the world. And because we have 7 panelists, I think the time management is also going to be of very great importance. So I humbly request all the panelists to keep strictly to time of about 10 to 15 minutes, and we'll take questions and discussions at the end of the session. There's a little change in the lineup of the speakers because Professor Nilma has to leave soon after this panel discussion. So let me introduce Professor Nilma Srisagar. I think she doesn't need a lot of introduction by now because now she's known to all of us. So she's going to talk to us from India about evaluating fixed dose combinations. She's an emeritus professor at Maharashtra University of Health Sciences with numerous awards to her credit and holding many international as well as national positions, including being member of the WHO Product Development, Drug Statistics Methodology, Malaria Policy Advisory Group, and so on. There's a huge number of positions that she's holding. So it's my great pleasure to invite you to do the first panel discussion.
Thank you very much once again for the wonderful conference that we are seeing and all the presentations this morning and yesterday. Privilege for me. So I'm going to speak on this topic of evaluating fixed dose combinations. As those of you who were present yesterday would recollect that in the prescription research that we were doing in India, we had nearly half of our prescription being with fixed dose combinations. So I'm going to speak with giving a little bit of background, a bit of global scenario, and then experience from India. And I'm going to move away a little bit from the science that we've been hearing since yesterday and today about the commerce, how it dominates. And then I'm going to take you to Parliament and what the elected representatives did. And then finally, the High Court drama and the Supreme Court actions and what the lawyers tell us and how we have to ultimately listen to them as well. And then the subcommittee, the fixed dose combination reviews that we did, and hopefully way forward. So we all know about the advantages of fixed dose combination. I don't even have to go through this slide except saying that we heard Marjorie and Lauren's presentation having to take 10 drugs. One of my friends was prescribed 3 anti-diabetic and she left that doctor because she thought there were too many. And she went to another doctor who prescribed her 1 fixed dose combination and she's been very happy with that. So advantages of patient happiness, if not anything else. Of course, there are challenges of overuse, misuse, increase in cost can happen because some unnecessary drug get prescribed there. And then there are these issues of the regulatory framework, the approval process, and the assessment and the clinical trial designs are not easy with the fixed dose combination. Just a little bit of global scenario. It's not only in one country. It's not only with one set of drugs. We have, out of total antibiotic prescription, 22% are due to fixed dose combination. And many of them are not even approved in WHO essential medicine list and so on. So even the ones which are approved by the WHO, there are some which are from the reserve group, some are on highest priority drugs, and many of them are even then not in the essential medicine list. So this is the list. I'm going to skip this. Here's the different countries, how much they use fixed dose combinations. Numbers in India, as you see, quite high. That top little thing on the top shows Sri Lanka, you don't have too many, at least as per this record, of antibiotics. I don't know about the other drugs, okay? So here we go now with what happened in India. So in India, all fixed dose combinations are considered as new drugs. So they need approval of the central licensing authority. The state licensing authority, after the central licensing authority issues the license, they can then provide for the manufacturing, marketing, and the sales control. There is also mandatory to have a post-marketing surveillance. After 4 years, anybody can get approval more easily. So all this was happily going on, and then came in 2005 the TRIPS agreement, as you know, which required the globalization, and then we also had the National Essential Medicine list that came up, and then came the big thing of drug price control order, which controlled the prices of many drugs. Now that put a lot of pressure on the Indian pharmaceutical companies to maintain their growth trajectory. So in those years, India witnessed a huge increase in the number of drugs which got approved. Nearly 12,000 fixed dose combinations were approved officially. And then, despite the rules, the state licensing authorities also approved a number of fixed dose combinations. And then there were many brand names. So the actual numbers became more than 6,000 even. The central drug authorities were very busy with lots of other things, so they took no notice and much action on that. This slide, if you just look at the top part of the this one, you'll see that there are 124 non-steroidal anti-inflammatory drug combinations, and that made to 3,000 brands. And look at the amount of money involved in all of this. That's 118 million INR, and you can calculate the currency. So by then, the electorate representative thought this is getting a bit too much. So the parliamentary standing committee said that the central drug authorities are not really safeguarding the health of people, and they should do something. So the licensing authority wrote to the state licensing authority, and they said, now you ask from the companies on what basis they are having this fixed dose combination. So 6,000 submissions came in. And they said they want more time. So by then in 2013, the central licensing authority came up with some guidelines as to how to deal with fixed dose combinations. And then where the legal battle started. The Professor Kokate, a very renowned person, and he did an excellent job. The committee was appointed, and Vikas here was a member of that committee. They looked at more than 6,000. They did a great job. They very quickly perused that. They said half of them looked rational, 15% very rational, and the remaining they were still looking at it. So based on their report, 344 fixed dose combinations which were confirmed as irrational were banned by the government. Now, the pharmaceutical companies appealed to the High Court, and they got a stay order on the ban. And this was called as the Great Indian Drug Ban. Why was it called like that? Because, as you see, the amount of money involved was phenomenal. Here's the type of drugs, but look at this. And it was not just Indian companies. Abbott, Pfizer, they all were into it. And look at the amount of money for each of these drugs that was involved. So they went to High Court, and High Court said, okay, they stayed the ban. What was the reason for staying the ban? They said, because we were not given hearing. So anyway, the government appealed to the Supreme Court and a special leave petition, and Supreme Court then gave a judgment. They said you should have a committee that will look into this. And importantly, what the Supreme Court said is that you should look at the risk, the therapeutic values and therapeutic justification for the ingredient. So they talked about the science part of it. And then they said you should, this is the legal thing, that you should be able to give the grounds and reasons as to why you consider these three factors as important. And you should recommend whether you can regulate, restrict, or need to prohibit them. Do you need to ban them, or can you do with regulation and restriction? And importantly, they said, you give a hearing to all the stakeholders, the pharma companies, the activists, the patient groups, the professional association, and that was what was work. So that was the committee which I was heading, and that's the work that we were to do. So we asked all the companies and everybody to submit the data online. And we followed the criteria for evaluation, the criteria given by Supreme Court, whatever is in the Act and the WHO guidelines and so on, and the information submitted by the stakeholders in the prescribed format. And we also had a set of 60 experts to look at the literature and standard treatment guidelines and gave a hearing. So we had to look at risk. So obviously we are all familiar with this. I'm not going to go through this, whether there is any side effects, if the kinetic mismatch, non-essential, irrelevant, abuse potential, narrow therapeutic margin, antimicrobial resistance likely, and ill-defined patient population, so that can lead to overprescribing, and the rationale is not good enough, no evidence for it, the dynamic inappropriateness, and no standard, not as per standard treatment guidelines, and they have antagonistic action, no relevant information. So we looked at all of these things. And the thing that we had to state was also that the grounds and reasons why we are doing what we are doing. So we had to say that it's not in public interest, it's injurious to the health of people, it's burden to the pockets of poor man, and it can result in delay in treatment. So the whole lot of things we looked at. The system can get overloaded, they're not as per treatment guidelines, and there are risks in it. And then there, as per the Act, the 26A, it can, whatever action we recommend, okay. So I'll skip this. So ultimately, we had 812 representation from 184 fixed dose combination. And we had to give hearing to 467 companies on 156 fixed dose combination, and so we held many meetings, including for the activists. Luckily for us, many of these companies form groups for the FDCs, which was common to all of them. Here's a list of what the activists said. They talked about antimicrobial and analgesics, and they talked about antibiotics. And then here's what the Dermatology Association, they have had grave problems with dermatological preparation containing steroids, the fairness creams, and they said this is dangerous really, and they'd seen many cases. So we, of course, noted, not surprisingly, because these were all the ones which were already actually banned by the previous committee, that there are several reasons for really considering them for ban. So these were various reasons. I'm going to illustrate with some of the examples. You can see here, we had asked them to give references, and the publications were not relevant, because, for example, the publication contained for gel preparation. Another one which was there was the study was done in Iraq, not in India. Then another one was, although published in BMJ, the study design was not good. We heard about RCTs. No blinding and no proper endpoint. Another one, the references submitted was all in Russian, and we could never get the translation. And then they said that something is marketed in UK, and so it's similar to international. But we find that's not true, because the preparation in India contained caffeine and different concentration. The one in UK, well, we didn't agree with this one as well. But anyway, we said that ours is not good enough. And then, of course, the kinetic mismatch, something is given once a day and the other one is given 3 times a day and put it in a fixed dose combination, so no good. Some of these combinations were such where they contain mecobalamin for diabetes, no good a thing. Then they had tropical pulmonary encyclopedia and asthma. One drug was applicable for one, the other one, so no good. Azithromycin for falciparum, so these were the kinds of drugs. So anyway, we said that out of these 349, our committee said 343 should be prohibited, and 6 to be restricted, regulated, and some needed more specific indication. And so the government acted on it, and they banned all this. So again, the companies went to court of law. The Supreme Court asked this now some of them to be again sent to another committee. Not all of these, but some had to be for various legal reasons again. Then the other set of fixed dose combinations came up, 322. And again, we had to go through the similar process. Now here we had now the lockdown. So now we couldn't give them personal hearings, so we had to give them hearing through video conferencing. The first time that we gave our recommendation, we gave in this kind of a format. We are all very familiar with its tabular format. We are very happy with that. And we gave, I'm sorry you can't see this, but here we gave the reasons why this is not good, and that was it, whatever we had got from the literature. And then we had the lawyer to advise, and the lawyer said that, no, that's not good enough. You need to give reasons why what they have said is wrong. So we changed our format. So we put for every fixed dose combination in this kind of a format, and we gave reasons why what the references which they had given is not in order, and why we thought that FDC need to be banned or restricted or whatever. So we had this, I'll give 1 or 2 examples and then I'll close. So here we had a combination of diclofenac and the thiacolchicide, and the study design again was not good enough to tell that the combination is better than one. Another one was with public opinion leaders saying that this combination is good. So again, that one was acceptable. Another one was combination of clomiphene with another drug. Neither were good for male infertility. This is an interesting one because often we find erythromycin and similar antimicrobials given along with that lactic acid bacillus combination, and that's a very commonly used fixed dose combination. We have several reasons to consider this as quite irrational. Important being that you need to continue the lactic bacillus for a longer time, and the dose of it was really not active enough. Many other such reasons are there where duration is important. Another one is you need to have sucralfate acid medium and an antacid is combined with it. Then you have not compatible kinetically, and the ingredient is not approved in the route proposed. Multiple ingredients and not as per standard treatment guideline. People may be familiar with this kind of, many such things are for liver diseases and various not as per standard treatment guidelines. I'm just going through these. Okay, so I'll skip all these to keep in time. The last point is about perspective of stakeholders. The healthcare professionals do like to prescribe fixed dose combinations. If they're rational, and then that's fine. Patients like the fixed dose combination because they don't have to take too many tablets. The important role that the civil society and the advocacy groups play is really crucial, and also the regulatory authorities, and evaluating fixed dose combination is sometimes a bit of a challenge. So let me skip through all this. And yesterday we heard pharmacogenomics. There's another issue of the fixed dose combination and interactions. And I acknowledge the members of the subcommittee, and thank you all for your attention.
Thank you, Professor Srisagar, for that very complete talk, yet another one very well delivered. And we thank for all your efforts towards making this conference a success. Next, I have the very pleasant task of introducing Chiranti. Chiranti Liyanage is a specialist in rheumatology and rehabilitation. She's also senior lecturer in the Department of Pharmacology at the University of Colombo.
Thank you, Dr. Sujivini. So I'll be talking about the experience of Sri Lanka in formulating the National Action Plan for Medication Safety and sort of the lessons learned from it. So Sri Lanka is a low middle income country, but it's a bit of an odd one out because our statistics sometimes don't really tally with the rest of the low middle income countries. Our life expectancy is higher than the rest of this region, and we boast of certain health indices that are way better than some of the other low and middle income countries, as you can see here from the universal health coverage indicators. But what about medication safety in Sri Lanka? So what we have realized is that we have issues that are pervasive, that are present throughout the entire process, throughout our entire healthcare ecosystem, from regulation to procurement to storage, distribution, and throughout the entire medication use process as well. So for example, when it comes to regulation, this is from one of our studies, that we found that there are way more brands of medicines in the market than what is registered. This is from an island-wide study where we studied 100 medicines in community pharmacies. And every time there are so many reports of failures in the regulation. For example, this is from the immunoglobulin incident that majority of us are aware of, where there's a huge failure at multiple levels of regulation and in procurement. And every now and then we hear about how poorly equipped our mechanisms and systems are to ensure medication safety. And sometimes looking at the numbers that we see from different published results, we wonder whether these have actually been underreported in the media rather than overreported, because you can see the number of prescribing errors that have been detected in some of these studies. And even when it comes to dispensing, this is recently there was the death of a 7-year-old girl from I wouldn't say it's just a dispensing error, but the primary reason that ended up being a dispensing error. And this is from a study, I think, by Nithushi and her group, where you can see there are the amount of prescribing errors that they have detected in a fairly large number of prescriptions that they have studied. And even when it comes to our people, the ones who are administering these medicines, you can see that the health literacy in our population, or the medication literacy, is quite poor. And there are loads of people who are self-medicating themselves, even with prescription-only medicines. So problems in medication safety are everywhere in the entire health system in Sri Lanka. In such a situation, why would our experience in ensuring medication safety, in implementing this medication safety action plan be different? Our situation is compounded by the fact that we have a very complex healthcare ecosystem. We have the public health sector and the private health sector contributing more or less equally to the healthcare delivery of the population. We have the allopathic system and also a fairly big complementary medicine system where people go in between these two systems, sometimes simultaneously using both systems. We have a regulated pharmaceutical market and a fairly big unregulated market where the medicines are coming through back channels. And our healthcare workforce, we have those who are trained in different places. We have a lot of untrained pharmacists. So our system is very, very complex. In addition to that, we have a complex and a varied social demographics, the political instability, our economic situation, and the cultural milieu of the country also makes our experience quite different. So in such a complex system, when we are starting off with a blank canvas where there's nothing, how did we go about it? What really happened? So it all started in 2017 with the third Global Patient Safety Challenge of the WHO on medication safety. And with the efforts started in 2017, it culminated in the launch of the National Medication Safety Action Plan in 2021. So this was drafted well before, and it sort of finally launched in 2021, and different activities have been implemented since then. So what we have learned is that we had to use a systematic approach based on whatever data that we had, from published data, sentinel events, expert opinion and inputs, and to identify what were really the key issues. But the problems for us was that there was a fairly paucity of data, and our health records are rather incomplete, kept on paper-based health records. There weren't, and also even when it comes to incident reporting, that's quite rare. There are low rates of incident reporting, so there's very little for us to learn from in terms of formulating an action plan. But the good thing is that we had something to work on. We had the WHO framework where the 4 main domains were identified and the key action areas were identified, which you could use to formulate the national action plan. And we had to get all the stakeholders involved. So with such a complex health system, we had to get the state sector and the public sector, the private sector and the academics, the regulators, and everyone involved, and make them part of this process to ensure its sustainability and to make sure that it can actually be implemented. So, and this was done through different technical consultations and going through multiple iterations of it. However, when such a diverse group comes together, the interests could be diverse, there could be different agendas, and sometimes in Sri Lanka, there is poor collaboration between sectors and between groups. So that was a challenge. And although people say that too many cooks can spoil the broth, in this case, I'd say that it made it even better because the different perspectives, the different expertise that different groups brought together made the action plan much more complete. And then we also needed a particular group or an institution to have that administrative responsibility on taking this forward. So the Directorate of Healthcare Quality and Safety in Sri Lanka has played a key role in getting the action plan up to now and also implementing it and monitoring and following up. And the other key players, including the Ministry of Health, the regulators, both in terms of the NMRA and the other SLMC and the other councils, and also us as clinical pharmacologists and academics have a responsibility, but the directorate has taken the real responsibility in administering most of it. And of course, when it comes to a national action plan, political commitment at a higher level becomes crucial. And when there is political commitment, the systems will fall into place or will align, and that then the economic funding will follow in a sense. So we have been very fortunate, as Priyanka and the others also mentioned yesterday, that the Ministry of Health has been very supportive of a lot of the activities. And in Sri Lanka, although there is a political instability, we've somehow been able to get the support that we need. And when it comes to implementation, we all know that failures in medication safety happen because of problems at multiple levels. It's never just due to a single person or a single incident. There has to be a failure at multiple levels for a person to come to harm. So implementation has to be and had to be multi-pronged. It can't just be one thing and then you move on to the next. So through the National Medication Safety Action Plan, all key domains have been addressed including putting systems and practices into place where a new medication incident reporting form has been implemented and introduced, where the incidents are being monitored by the directorate. And we also have got the KPIs in place where it should be monitored at a national level. So this is the medication incident reporting form, which is sort of being collected, and the data is being collated by the directorate. And then it looks at the healthcare professionals on training them on the continuous professional education, in service training, and also in equipping the healthcare professionals with the knowledge that they need by local publications, including sorry about that, the student formulary, which was published by the Colombo Medical Faculty. And we spoke about the prescribing safety assessment, which hopefully will be introduced in the near future. And the action plan also looks at the medicines, on how to make that safer. We have got the lookalike, sound-like medicines and the high alert medicine lists, which have been formulated now, and that details which will be disseminated. And it also looks at the patients, on empowering the patients, improving their literacy through different initiatives, different actions. And this is one of the media campaigns that happened way back in 2017 to targeting improving the knowledge of patients regarding medicines. And another good thing about the National Medication Safety Action Plan in Sri Lanka is that it's inclusive, and it tries to achieve equity and looks at different groups, different disadvantaged populations and minority groups. So the medication labels that are being proposed are to be in all three languages, all three main languages in Sri Lanka. And it also includes sections on people with visual and hearing disabilities, which I know is a personal interest to Professor Chamari as well. This is from one of her studies. The other thing is that being a resource-constrained country, we had to be cost-conscious and prioritize. And funding has to be sourced from many different sources. And we have to resort to sometimes more cost-effective methods, innovative methods, and think of sustainability when we're trying to implement these. And these have to be delivered in ways that people can implement in different institutions and take it forward. And also, the National Action Plan in Sri Lanka gives the KPIs for it to be monitored, and there's the medication safety indicators that have been identified along with it, and regular monitoring of the actions will help implementation to learn from mistakes, to improve ourselves further. And finally, to have all this going on in a challenging situation with COVID, with an economic crisis, we had to have the proper leadership, the team, to keep this momentum going. And I think everyone would agree that Professor Priyadarshini has been the driving force to get all of this here, and those of you who have worked with her long enough would know that saying no to her is not an option. So we have learned never to say no to her anymore when she asks us to do something. So that's the type of perseverance that you would need to really get something done in a challenging setup where resources are constrained. So we've brought multiple players with diverse skill sets, administrators, academics, and researchers to get it where it is today. So we have learned that implementation takes time, and there are many challenges, but we just have to keep going and find ways around it. And there needs to be a focal point. Here it's the directorate, and with the University of Colombo supporting, of course, to keep things going, and regular monitoring always helps implementation. We need the involvement of all the stakeholders And funding, we have to look for it in different places, source it from different places, and we need to ensure that higher level commitment is there to continue our efforts going. So we do have a long way to go, and we might even be slower than the tortoise, but the way forward for us would be to regularly review the activities with the KPIs and to identify priority areas, particularly when our resources are constrained, and do what is achievable, and to develop next year, to review and to develop the action plan for the next 3 to 5 years, and to try and implement these activities across all settings, across all levels of healthcare institutions, and to keep the momentum going. Thank you.
Thank you very much, Chiranti, for that excellent talk and thought-provoking messages that you conveyed to the audience regarding the Sri Lankan National Action Plan on medication safety. So let me introduce our next speaker. It's Professor Caroline Semer from Switzerland to talk about experiences from Switzerland about medication safety activities. I think Professor Caroline does not need a lot of introduction now, having spoken before this and being with us yesterday as well as today. So Caroline Semer, Professor MD of Pharmacology and Clinical Toxicology at the University of Geneva, Head of the Department of Anesthesiology, Pharmacology, Intensive Care and Emergency Medicine, and Head of the Clinical Pharmacology and Toxicology Division at Geneva University Hospitals. Over to you, Professor Caroline.
Thank you very much. So I was asked to talk about the experiences from Switzerland. I must say I'm very impressed with what's being done in Sri Lanka. So I will describe our experiences both at the national level, but mainly at the hospital level. So you see here the Swiss Federal Council Quality Development Objectives for 2022 to 2024 that are divided into 5 areas. And I want to focus on that one, saying that patient safety is actually one of the 5 objectives of the Swiss Federal Council. And when looking at patient safety, you see that there are 2 4-year objectives. One of them being service providers operate a clinical risk management system for their area of activity, and specifically stating that service provider avoids adverse events and harm to patients, irrespective of their social disadvantages and health competence. They systematically and sustainably apply evidence-based practices to prevent adverse events, following the recommendation and action plan of the WHO Global Patient Safety Challenge, Medication Without Harm. So you see that in 2022, the Swiss Federal Council specifically put the medication without harm in the objectives for the next 4 years. So in Switzerland, we have national implementation program from the Swiss Patient Safety Foundation. And since 2012, the Patient Safety Switzerland has been running a series of national programs called Progress. These are pilot programs aiming at promoting patient safety in Switzerland, and they're part of the federal strategy for quality in the Swiss healthcare system. So there were 2 programs on medication safety, one on medication safety at the interfaces and one on medication safety in nursing homes. So regarding medication safety at the interfaces, the focus was on medication reconciliation. As was said earlier this morning, medication reconciliation aims to ensure accurate and comprehensive medication information transfer during patient handover to decrease the risk of medication error by systematically compiling an exhaustive list of drugs and preparation taken by the patient and ensuring using this list methodically when prescribing medicines. And I'm not going through the 3 steps that have been presented earlier this morning in order to take the best possible medication history. So the list of medication has to be complete, and in Switzerland the aim was to have at least 2 sources of information and at least a structured interview with the patient. So various communication measures were designed and developed to raise awareness among specialists and the general public of the problem of medication error at interfaces and the effectiveness of those measures. And there was a pilot project with 8 hospitals who participated in the 3 linguistic region of Switzerland in order to test whether medication reconciliation is feasible in hospitals in Switzerland. So you see here some of the communication that was developed. This is the 5 questions patient checklist that was developed. I made the translation with some artificial intelligence with DeepL, so this is why it's all mixed up. But the 5 questions are regarding the changes, further treatment, the correct use, treatment monitoring, and follow-up. There was also a medication plan that was developed for patients, listing all medication, including vitamins, OTCs, and herbal medicines. And that's a document that was developed for the best possible drug history interview guide with 10 tips for an ideal drug history. You can find all these documents on the Swiss Patient Safety website. So what experience did we gain from the 8 pilot hospitals? First thing was that the process and the recommendation for implementing the best possible medication history proved to be useful and feasible in the Swiss context. Roles, tasks, and responsibility of the professionals involved in the different hospitals varied. So the hospitals could choose the best model for them. So there were 2 models. One was the medical staff model, where junior physicians were responsible for taking the best medication history. And there was a pharmacy staff model, where a pharmacy assistant or a pharmacist was responsible to record the medications. At the end of the project, no clear recommendation could be made whether one model is better than the others. There were advantages and disadvantages in each of the model. The medical staff is quite busy, like everywhere in the world, so it takes time to do this medication reconciliation. So that was one of the disadvantages, but at the same time, the medical staff is responsible to know the list of medication the patient is taking. And in the pharmacy staff model, it was a good experience because the pharmacy staff had more time to take the medication history, but then there were sometimes fragmentation, communication problem between pharmacists and doctors. So both models have their advantages and disadvantages. So what were the obstacles and success factors? So we need leadership and management support. Working with interprofessional projects can have some issues as well, but the experience was that the medical profession has to play an active role at all hierarchical levels, so from junior doctors to senior doctors, for it to work. We also had hospitals who chose specific target population because this has an impact on the organization of the daily work. So it's, of course, easier to do medication reconciliation with elective patients than with emergency patients. There's a need for staff training and for acceptance of the teams. Regarding the sources of information for drug history, it's time-consuming. Clear responsibilities have to be set, documented, and this requires good coordination and cooperation. And regarding documentation, that was also an issue. We need really integrated, easy-to-use IT tools and support from the IT people to help with this reconciliation. In hospitals in Switzerland, we have electronic health records in all our hospitals. So the next steps for this reconciliation is a clear commitment from healthcare institutions, associations, and political players. And there's been a charter, medication safety at interfaces, that was developed by the Patient Safety Foundation. And they asked all relevant stakeholders to sign this declaration, and it can be found on their website. The other pilot project was medication safety in nursing homes. The aim was to reduce adverse drug events among nursing homes residents in Switzerland, and it focused on 2 central themes: reducing polypharmacy and reducing potentially inappropriate prescribing. The aim was to develop and adapt context-specific improvement measures, conduct a pilot phase in selected nursing homes, and verify their feasibility and effectiveness. Quality standards were defined. 5 quality standards were defined via a Delphi method to describe the minimum requirements for medication processes and professional collaboration to achieve the goal of safer, resident-oriented medication. They focused on the review and monitoring of residents' medication, involving all professional groups involved in the medication process, as well as the residents themselves, the target group being doctors, pharmacists, nursing staffs, as well as patients. So I show you here the 5 quality standards category. And if we look as an example to the first quality standards, medication is reviewed regularly and in defined situation. A medication review is performed regularly for each resident. Regular reviews should be carried out at least every 6 months. The date of the next regular review is recorded in writing individually for each resident, and a design professional is responsible for managing the deadlines. So what are the defined situations? You see here the list of defined situations where this should be done. So any significant changes in the general state of health, vital parameter, or lab values, new admission, readmission, etc. The nursing staff report each of these situations to the doctors. As soon as they became aware of them, the doctor is responsible for conducting the medication review dictated by the situation, and the review is carried out for each defined situation. Some material was developed in that pilot program to implement the quality standards. A range of material was developed in cooperation with scientific partners in 3 areas. To promote professional knowledge and awareness, to promote interprofessional collaboration, and to promote tools for implementing the quality standards. So these are the training and tools that were developed in the 3 Swiss languages, German, French, and Italian. And they can be found for free on the patient safety websites. So the quality standards, there were e-learning modules that were developed for physicians and pharmacists with a specialized continuing education in geriatric pharmacology, on interprofessional collaboration for all professionals, and for nurses and ancillary care staff. Observational instruments were also developed, a tool called Stop and Watch and an ADR tool, and instruction and recommendation form for standardized pharmaceutical verification. So you see here the Stop and Watch tool that's used to identify non-specific changes in residents, such as changes in behavior or need for assistance. And this is designed as an early warning tool to help to identify possible changes as early as possible in a structured way. The ADR tools help professionals to identify adverse drug reactions. So it lists the most frequent adverse reactions here and the common drugs prescribed in nursing homes. And it helps to identify early those adverse drug reactions in nursing home. And this is the tool that was developed for pharmaceutical verification of medication with instruction and recommendations on how to perform that standardized pharmaceutical verification. In Switzerland, we also have a non-profit organization called Smarter Medicine, Choosing Wisely Switzerland, that aims to encourage activities and intervention to optimize drug treatment, avoid unnecessary medical tests, treatments, and procedures, such as unnecessary drug treatments. Less is sometimes more against overtreatment and incorrect treatment in medicine. So a top 5 list is developed by each national association, specialist association in Switzerland. So there is one for the Swiss Society of Clinical Pharmacology and Toxicology. There is one for anesthesiology, cardiology. So the aim is to publish a list of 5 items, medical measures that are unnecessary and backed up by scientific evidence. There is also a top 5 list, 5 questions before treatment for patients. So these are some initiatives at the national levels. What happens at the hospital level? So this is what happens in my hospital at Geneva University Hospital. We have a hospital medication risk management plan, and we have the stages of the processes around medication, so history, prescribing, management of central pharmacy, dispensing, preparation of injectables, administration, follow-up, transfer, discharge, reconciliation, and we have more transversal tools, training, evaluation, and feedback. And we have identified risk for all of these stages. So I'm gonna show you for each of these stages what has been practically done at the hospital level. So regarding history on admission, we now have an electronic tool that's linked to the electronic prescribing system to enter home care and discharge treatment and to document medication history. We've also been working on a direct link with the medical dossier to import the medication list of the patient. And we also supplement the doctor's medical history with a second interview by a clinical pharmacist. We're lucky to have clinical pharmacists in our hospital, but we do not have enough clinical pharmacists, so we focused on high-risk patients. Regarding prescribing errors, we have computerized prescription tools with decision aids. So we display a clinical risk for each prescription, and we are developing, as clinical pharmacologists, alerts for high-risk drugs. We have put in place an opioid converter and tools for safer heparin prescription. We have developed specific computerized tool for anesthesiology and intensive care unit. And there are also specific projects for nephrotoxic drugs in pediatrics. Clinical pharmacists attend visits regularly and they review drug therapy for patients and drugs at risk. And we have a specialist clinical pharmacology and toxicology consultation. And we have focus on psychopharmacology, geriatric pharmacology, oncology, transplantation, HIV patients, and polypharmacy. In Switzerland, electronic health record and computerized physician order entry systems have demonstrated to be effective. Most Swiss acute care hospitals have them. And there is a federal Swiss mandate that by 2020, all Swiss acute care hospitals and by 2022, all nursing homes must transfer relevant data to electronic patient record at discharge. We have several softwares, and all the established electronic prescribing systems in Switzerland have built-in interactions checking softwares. I've shown you here some example of software that's been used in different hospitals. And we are fortunate to have clinical pharmacologists and toxicologists in each university hospitals actively involved in patient care, optimizing drug treatment, being active in pharmacovigilance, in drug and therapeutic committees, and in education and research. And this is a study that was conducted in the UK showing that each pound spent to hire an additional clinical pharmacologist has the potential to reduce the NHS cost by almost £6. So I highly recommend this publication done by PricewaterhouseCoopers if you need to make a case to have more clinical pharmacology in your country. Regarding distribution errors at the pharmacy, we have a robotization of distribution, in particular for narcotics and refrigerated medicine. We scan items that are not stored in the robots. We have stock management professional and electronic tools to manage supply disruption. Regarding storage failure in care units, we have pharmacy assistants deployed in all care units, and we have these automated medicine cabinets in most units. Regarding dispensing errors, of course, computerized prescribing help. We have a drug information center at the pharmacy, automated medicine cabinets. We've developed nursing courses. We increase the proportion of medicine dispensed by names, etc. So in Switzerland, there has been advances in drug distribution and management in hospital settings. Institution hospital pharmacy are equipped with blister packaging equipment. We've got those electronic medicine cabinets on the wards of numerous acute care hospitals. And a survey of 48 hospitals in Switzerland showed that 61% of hospital pharmacy involved pharmacy technician in managing ward pharmacies. Regarding errors in the preparation of injectables, we centralize cytotoxic preparation and the monoclonal antibodies in the pharmacy. We have standardization of dilution and labeling, ready-to-use injectables. We have developed this nursing course. We have also developed e-prescribing system for intermittent and continuous injectables. And we have tools for calculating infusion rates. And again, at the Swiss level, since the mid-90s, Swiss hospitals have been realigning their approach to drug compounding and preparation. Nowadays, the preparation of those high-risk parenterals and for high-risk patients is centralized in almost all acute care hospitals. Regarding administration errors, patients are identified with a wristband and there are monitoring guidelines. There is bedside scanning for cancer chemotherapies and high-risk medication. Selection of medicine have correct unit dose identification. We've put in place smart pumps and stoppers catheters for intrathecal access. And there is an independent double check for complex dosage calculation and pump programming. In Switzerland, again, we've been limiting the different types of infusion equipment. IV administration of drugs, especially for high-risk drugs, is increasingly pump-controlled. We've been limiting the number of standard pumps used to a maximum of 2 models per type. And the 2015 survey suggests that it has been implemented to a large extent in Switzerland. Regarding failure to monitor and adjust treatment, we've got pharmacovigilance declaration and tools enabling patients to report ADRs. We have transfer rules to revalidate treatment when patients change of care units. And regarding discrepancies in the reconciliation of treatment, patients are given a treatment card when they get out of the hospitals. We've developed tools to facilitate medication reconciliation. There are therapeutic education interviews performed by pharmacists for high-risk patients. And now we have pharmacists developing a chatbot to recontact patients after discharge to ensure they are actually taking their treatments. And we are developing tools for patients to monitor their treatment. This is one of the tools. This is a tablet that all patients have at Geneva University Hospital. So they distributed their tablet when they arrive in the hospital. It's called Concerto. And there is an app in that tablet called SwissMed that helps patients keep their list of treatment, easily consult the future and past doses, set reminder alarm, improve their knowledge. There is a quiz to know more about treatment, about side effects, and to export a treatment card and intake history. There is another module called Diapason. It's a module enabling patients to report adverse reactions themselves. So there is a link between the electronic health record in the hospital and the tablet to import automatically all the medication of the patient, and the patient can himself report the side effects, and it is sent then to the clinical pharmacology department. Switzerland has a very strong pharmacovigilance system. I'm not going into that. I will just finish with the last point of the medication risk management plans, errors due to lack of skills. So we have developed courses for nurses, interprofessional training courses. We have a simulating place to train our staff in a simulation environment. We've developed what's called serious games on opioids and anticoagulants. And we have a good adverse event reporting system, a dashboard of indicators, and an audit concepts for the medicine use process. The critical incident reporting system, Simon mentioned about it yesterday, is now present in 24 out of 25 Swiss hospitals, and many Swiss cantons now require this system in their care agreements. So in conclusion, what's the experience from Switzerland? We have implemented and progress in with numerous national and hospital measures in the 4 domains and 3 key action areas of the challenge. There's been advances due to quality and safety measures. I've mentioned those listed here. But I have to say that all is not perfect in Switzerland. There is a need for a national coordination that there is not at the moment. In Switzerland, there is no national medication safety plan. We have different stakeholders, but there is no comprehensive national strategy dedicated to medication safety. We have a decentralized healthcare system and different cantonal healthcare regulation, which really complicates the implementation of a unified strategy, and a federal system with different stakeholders. We need to improve collaboration between physicians, pharmacists, nurses, clinical pharmacologists, and patients. We have not yet achieved the digitalization of the comprehensive digitalization of the whole medication process. And of course, we need to promote teaching and research on drug safety and prescribing at all educational level. Thank you for your attention.
Thank you, Professor Sama, for that very interesting and informative lecture. Next, I welcome Dr. Lauren Walker to talk to us on experiences from the United Kingdom. Dr. Walker is a reader in clinical pharmacology and therapeutics, an honorary consultant in general internal medicine. Over to you.
Thanks. So for the final time, it's lovely to speak to you about these next few slides. I'm very, very grateful to the UK Health Innovation Network, who provided me some of the first couple of slides here to set the scene of the problem that we're facing in the UK and the solution. And in particular, we're going to focus on structured medication reviews, and I'll tell you about those. But in terms of scale, you know, we recognise that we do have a big problem. You know, there are 405,000 people who are over the age of 75, 136 almost thousand that are over 86. And those are the biggest users of medicine, so nearly 1 million people taking more than 10 medicines. And it is a predominant problem of older, you know, some of the oldest old. And people taking 10 or more medicines are 3 times more likely to be hospitalised or suffer harm as a result. There was a study that was done about 20 years ago, which is often quoted, saying that 6.5% of admissions to hospital in the UK are caused or complicated by a medicine. We updated that study a couple of years ago, so almost 20 years later, and showed, because of the increase in prescribing, that number is now 16.5% of all admissions are caused or complicated by an adverse drug reaction. So it's a significant problem, that polypharmacy is a big driver of that. And we reviewed 1,000 medical admissions, myself and other clinical colleagues, so people who'd been hospitalised for greater than 24 hours. And in our view, 40.4% of those were considered, you know, we felt were potentially avoidable had there been an intervention with a structured medicines review. And you can see what the major culprits there were: diuretics, steroids, proton pump inhibitors, a huge problem for increasing your risk of community-acquired pneumonia and C. diff, diarrhea. And the cost to the UK health economy was 2.2 billion from those additional, either additional days of stay or hospitalisation in the first place. So that money could be reinvested elsewhere within the healthcare system. And this is not just a problem in England. This was a study that would say, we looked at hospitalisations. This was a study done in Ireland in the community, so in GP practices. They followed 592 patients over the age of 70 forward for 6 years and recorded a total of 211 adverse drug reactions, gives a cumulative incidence of 26% over the 6 years. And we know that females are more likely to suffer adverse drug reactions, as are people on more than 10 medicines. So that's what has prompted a big focus on what we call extreme or complex polypharmacy, which is taking 10 or more regular medicines. So those people should be prioritised. And if you look in a particular disease area, so this was a study involving 1,256 GP practices looking at hypertensive control. And although obviously the benefits of good hypertension control outweigh the risks for the majority of individuals, when they did a subgroup analysis, so they looked at people in the 80 to 89 years bracket and showed that the absolute risk of hospitalisation because of things like falls, in people with severe frailty, that risk was, was not outweighed by the benefit of tight hypertensive control. So in those older people with frailty, we should be looking to consider alternative approaches rather than kind of tight blood pressure control, because it can actually cause more harm than good in that population. And then just lastly, in terms of setting the scene for the problem. So in Newcastle, there was a study done in the north of England in patients over the age of 85, and each additional medicine that was prescribed was associated with a 3% increased risk of mortality. So in the oldest old, the risks and benefits of any additional medicine should really be considered because of all those risk factors I've listed below. Because my medicine services, heart failure, diabetes and kidney failure, a lot of our patients that we review are in that 85 plus age bracket. And it is challenging, and I do have to challenge a lot of my colleagues around, do we really, when they make suggestions about starting new medicines in an 85-year-old, that do we need to do that? And if we really need to do it, we should be exchanging one medicine for another rather than adding to the medication list if we can at all avoid it. Because people that are 85 plus don't make it into clinical trials, so the evidence base is not as strong in that age group. So because of the scale of the problem, that's what prompted a change to what we call the GP contract in the UK, so the direct enhanced service provision. And that introduced this concept of the structured medication review, which is an evidence-based and comprehensive review of a patient's medication, and it should be driven. This is a pharmacist-led intervention. So the funding went into creating a lot more posts for clinical pharmacists in the UK to deliver them. And the guidance that's available for them is that they should be offered to people in care homes, people with complex and problematic polypharmacy, specifically focusing on 10 or more medicines, that it should be drugs that are people who are taking medicines that are commonly associated with errors, and people who are severely frail, or people recently discharged from hospital, particularly relating to a fall. So that bottom one tends to be well managed in the UK by gerontology in our falls clinics. So it was the others that has been the major focus for the PCN, what they call primary care network pharmacists. So that means employing a particular pharmacist to work across a number of different community practices and just to provide those SMRs. One of the things I wanted to point out, though, is, of course, although we are living longer, and we are, in the UK, 3% of our 70 to 74-year-olds have dementia, which rises to 11% once you get to the 80 to 84-year-olds. 80% of people aged 90 and over are not living in a care home. And actually, it's only less than 4% of people who are in that older age bracket that do, in fact, live in a care home. And I think it's important to remember that a lot of our strategies in the UK have really focused on care home residents. But there are a lot of people that are still living independently. And what we don't want to do is create a health inequality by only focusing our services on a small proportion, actually, and that we should be make equal effort to maintain the independence of our community-dwelling older adults. And so it's just finding them that's the challenge. I think some of this is a logistical challenge. It is easier if you're employing an individual to deliver these medicines reviews to set them up in a care home, and it is easier to identify those patients. How we find them for people that are living independently is a bit tougher. So that's some of the challenge. So this really will be a pharmacist-led intervention, and the guidance is that it should be tailoring medicines to individual needs, and that it should be shared decision-making. So we should involve patients and their families, and quite often the MDT, because not dissimilar to Sri Lanka, we have a lot of organ-based specialists as well, lots of organ-based specialty prescribing, and although we'll have an integrated care record, people are very confident and protective of the medicines that they have prescribed, and it falls to an overstretched generalist, a general practitioner, to manage the expectations across the different organ-based specialists. So this is the project that I co-lead in collaboration with some computer scientists, which is Dynerics, which is Dynamic AI for Prescribing Support. And as part of Dynerics, we undertook a number of focus groups and interviews with people who are doing these structured medicines reviews to understand what the barriers are. Why is this difficult to do? And that involved a lot of patience as well. Why is it difficult for you to get a medicines review or the barriers to getting something decent out of it? And broadly speaking, those can be, there were lots of barriers, to be honest, but they can be brought into 4 categories: organisations, things to do with inequality, digital tools, and the amount of time taken for the detective work that's involved. So like I said to you before about trying to create these timelines of individuals trying to map the drug to the indication and what's happened, what's been successful in the past and what hasn't been, all of that takes an awful lot of time. In terms of the digital tools, there's the fact that they're spread out across lots of different web pages, they're not integrated into the care record, so again that adds to the time burden. And inequities was generally relating to that if you employ a PCN pharmacist to work across 4 different practices, but that area is particularly deprived, meaning that there are a lot more patients that have a lot more complexity, the value or the time available for that individual to undertake medicines reviews is very different to a more affluent area. Just a last sort of note on barriers, communication appears time and time again. So there are quite often medication, although the bulk of prescribing is done in the community, a lot of higher risk medicines are started in hospitals, and then whose responsibility is it to continue those, and there's no guidance on when to stop them. So that becomes a challenge. Not only did we ask participants about barriers, but we also asked them about what do you need to be able to do this work better, and they had a whole kind of comprehensive list of things on their wish list that they would like to see, and a lot of these are digital tools. So really what they were saying is they want tools that improve the efficiency, so it takes less time to do the prep work, so that they can spend more time explaining things to patients, because that shared decision-making part of the requirement for an SMR is time-consuming, and that's what people struggle with. So just some examples of some UK clinical pharmacology services. There are 3 Clinpharm-led pharmacology kind of medicines review services that I'm aware of in the UK. So the first one is the one I contribute to. So this is a tripartite arrangement. This is for people with heart failure, diabetes and chronic kidney disease. And we have 8 organ-based specialties involved that are listed there. So we all come together to do this as a group. And generally the patients are presented by the heart failure specialist nurse. And we were able to show a significant reduction in hospitalisation, specifically due to adverse drug reactions in people who, pre and post MDT discussion, alongside a reduction in all-cause hospitalisation, and importantly, a reduction in outpatient clinic appointments. So some of these, the more complex individuals are seeing 10 different organ-based specialists a year. So that's 10 different people who feel very confident in their area of prescribing, but less so in others. And it's very hard to, that's where the kind of the majority of drug interactions arise, actually. So reducing the outpatient burden and instead bringing the specialists together and discussing the patient. And then that patient just sees one individual rather than going to 10 different clinics, was more satisfying for our patients. There's another service that runs in London by a friend of mine, Professor Emma Baker, who runs an integrated pilot polypharmacy service that has 4 main strands. So they've been doing that for a couple of years now. So they do clinics, so face-to-face clinics with patients, but they also operate an MDT model, not dissimilar to the one that I do, but they give advice and guidance as well. So they have a system where GPs can ask them questions about the more complex patient and medication regimes. And then they do a lot of work in terms of community of practice, so trying to build up the confidence within PCN pharmacists to do some of this work, because although the investment in the UK went into employing more pharmacists to do this, there isn't an evidence base that they feel comfortable or confident to stop a lot of medicines because of the fear of litigious consequences, really, that it is very challenging to do. So when they did a review of the pilot service, they showed that they, on average, recommend 5.9 medication changes per patient, with a reduction in drug costs of £207 per patient per year. And it was quite a small service, a small review, but it does show that that we can make a difference. And then lastly, the only other service that I'm aware of that's led by clinical pharmacology in the UK is done out of UCLH. So they, again, so another one in London. This is a joint clinical pharmacology and pharmacy-led service where they review patients that have been discharged from hospital. So again, one of those key critical tipping points where we see a lot of medicines-related harm. So they did 24 reviews, again, a reduction in a median of by 4 medicines, resulting in a cost saving of nearly £5,000 UK pounds. So again, it adds evidence or weight to the evidence that we can save money by doing this well. And this is very different to some of the pharmacist-led interventions that we see in the UK that are around, that are focused on changing or swapping a high-cost drug to a low-cost alternative. This is very different. This is about reducing medicine's burden overall, so stopping medicines that were inappropriate in the first place. And I think that was everything. Thank you very much for your attention again. I really appreciate it.
Thank you very much, Professor, for that very detailed presentation and giving your insights about the matter. Next, we have Dr. Sagari Kirivandeniya. She's a consultant medical administrator, and she began her career as a medical administrator in 2006. She has held significant leadership positions, including medical superintendent at Base Hospital Panadura, director at Colombo East Base Hospital, and director at De Soisa Teaching Hospital for Women. Currently, she serves as the director of Colombo South Teaching Hospital. Throughout her career, Dr. Kirivandeniya has effectively led hospital teams to achieve productivity and quality improvements, earning national level awards for various hospitals. Over to you.
Thank you very much for the introduction. After listening to many these scientific presentations, actually my presentation will be a very practical one. What is happening in the ground situation in Sri Lankan hospitals, I'm going to present. So thank you very much for inviting me, Dr. Galapathy, for these very important sessions. So ladies and gentlemen, in my presentation, I'm going to discuss about the administrative and management decisions and process improvement activities which we have done in our hospital, and the improvements in pharmacy level and also the our ward level, which we are focusing, the improvements we are focusing on medication safety. So I'm going to skip these slides because considering the time which we are already behind the time, and 5 rights to ensure medication safety, we have to look into that always. So my hospital, Colombo South Teaching Hospital, is the second largest hospital in Western Province. It's a teaching hospital. It's a teaching hospital of Sri Jayawardhanapura University. And we have the most crowded OPD. It's about 1,300 OPD patients visit the hospital per day, and about 1,800 clinic patients are there in different clinics. So we have 2,956 staff members, including 81 consultants and about 250 medical officers. 1,242 beds we have, with the bed occupancy rate more than 80 always. There are, in some wards, maybe more than 100 bed occupancy rate. 430 in-ward discharges and 465 in-ward admissions. So I wanted to present these statistics for you to think about how much of medications we use and how much of patients we are treated. So we started our medication safety activities with the Patient Safety Day, with the slogan of medication safety. And we first of all, we did a symposium with the help of Sri Jayawardhanapura Clinpharm department. We had some sessions and also the panel discussions in the hospital to make the awareness of the staff about the medication safety. Then we established a medication safety committee in the hospital, consists of administration, clinicians, and also the pharmacists. So there we discuss about the medication safety activities in the hospitals and how they implement in the hospitals. So the committee conducted a research in the hospital to analyze the degree of adherence of documentation in the drug chart to WHO standards. So there were 923 drugs were prescribed in 200 bedhead tickets with the mean number of approximately 5 drugs per BHT. So it is nice to notice 88.5% of prescriptions contained at least one error. And there are some other results. I'm not going to read all these things. Minimal errors in dose. There were about 2.9%, and frequency about 1% was documented. None of the prescriptions contained the prescriber's signature. So this is worth to notice and do the intervention. So there were so many other findings we found. So we took some interventions in the hospitals. So we have done digitalization in some of our units. Our OPD is digitalized and we are having a paperless OPD. So we give the electronic prescriptions to the patients. And our medical clinics, nephrology clinics, diabetic clinics, cardiology clinics are digitalized. We are prescribing electronically. And radiology department also we are managing with the PACS system. And some departments of laboratories, especially the hematology department, biochemistry, we have already digitalized. So as we are registering electronically all the outpatients and the admissions, by now we have registered around 593,000 patients in our hospital. So we are having Hospital Information Management System, HIMS. So we can do proper patient identification with the help of this HIMS. So all admissions and OPD patients are registered with personal health number to improve patient identification. So we issue this health service access card. In that access card, there is a barcode. It is embedded with national identity card and patient other information. So HIMS helps prevent medication errors by providing a clear electronic prescription and dosage, and also this reduces the likelihood of administering the wrong medication or dosage. And also we have up-to-date patient records due to the HIMS. This ensures that they have the most current information about a patient's medical history, allergies, medications, and previous treatments, reducing the risk of errors due to incomplete or outdated records. So this is our HIMS. We have notifications of allergic drugs, system alerts of allergic prescriptions, and previous visits and diagnosis can be seen. So we have taken many strategies in the pharmacy level by our pharmacists to safeguard the medication errors. So one is stored high alert medications separately and high alert medications removed from fast moving areas to prevent grabbing accidentally or grabbed by unauthorized persons. So you can see in the left how it was, and we have done improvements in the right side. So using high alert medication stickers and high alert medication auxiliary warning labels in red color to differentiate high alert medications. So we are having less resourced setups in our wards. As the other speakers mentioned, we don't have electronic medication cupboards or electronic prescribing dispensing cupboards. So all the things are done manually. So these things are very important for us in our ground level to prevent the errors. This is also using auxiliary warning labels for high alert medications. You can see in the right side, the auxiliary medication labels are there, and as the strengths are different, we have used the 2 different colors. So this is look-alike, sound-alike medication. So stickers and the auxiliary warning labels are used in the pharmacies. So you can see the both labels are in the same cupboard, like high alert medicines and the look-alike, sound-alike medicines with the stickers. This is another way of doing. We have packeted medicine to dispense the patients with different labels to prevent labels for pre-packed LASA medicines to identify them easily, by which also we can prevent the medication errors. So this is using Tollman letters to differentiate LASA medicines from their LASA pairs. You can see here clonazepam and diazepam together. So by using this type of labeling, we can prevent the errors. Providing dispensing labels in 3 languages with pictorials for pre-packed medicines to educate clinic patients. We have different kind of patients in our hospitals, multi-ethnic, and also the educational levels are different. So these things are important for our patients. Providing special detailed dispensing labels in 3 languages with pictorials for high alert medications to educate clinic patients on their medicines. So these things we do inside the hospital with the help of pharmacists and the clinicians, and we use these things. Then providing leaflets with special instructions when issuing special medications to deliver proper dosing instructions to patients in their native languages. This is also done by the pharmacists with the help of clinicians. So displaying, educating posters for patients, this we have done in everywhere where the medicines are used or prescribed or dispensed in the pharmacies, wards, and the clinics. Counseling first visit clinic patients is done in some clinics of our hospital by the pharmacists. And the leaflets are used in both languages for them to use in these sessions. And also one pilot projects we have done in our cardiology department. Usually our ward patients, when they are discharged, they obtain their medicine in the dispensaries. They have to go to the dispensary and get the medicine. But we have done this pilot project to deliver the medicine on the bedside by a pharmacist in the ward, by which they can do the education sessions for the patients and educate the patient regarding the side effects and the way of taking the drugs and the way of their using the devices as well. So the patients are also very happy, and it is easy for them. And we also provide drug dispensing envelopes in 3 languages, English, Sinhalese, and Tamil, for patients instead of wrapping medicines in a paper. So earlier we wrapped the medicines in a paper, but now we have improved it in most of the hospitals. But we are using the in 3 languages we have printed these envelopes. So this is also the pre-packeted medicines which we issue in the dispensaries. For that also we use the labels in different colors and also in 3 languages. Some strategies we have taken in ward level as well to prevent the medication errors and harm. We have always using visual control systems if possible, and drugs stored accordingly to the alphabetical orders Some various rows have various colors. Different methods are used in different wards to improve the medication safety in our wards. So expiry dates displayed according to the traffic light system, and first in first out method is used always in the drug cupboards when we are storing the drugs. So this is one of the drug cupboards in our ward. So always we are keeping it in the alphabetical order. Any nurse can work in any ward and they can easily access to the medicines as we are using the system in the unique way. And storing, and we are concerning on expiry days. You can see the stickers are labeled using the expiry years. And this is also the way of storing. Here we can see, you can see the filling levels are also there, and the numbers of bottles are there. We can refill easily, and we can use first which came first. So this is again how we have using the expiry date, concerning the expiry date in the cupboards. Thermometers we are using in the refrigerators. Refrigerators also manage well. External label shows inside drugs with expiry dates. Visual control systems are applied for easy identification, access of drugs. Various colors for various drawers were used. Food are not present with medications. We can find sometimes this happens in some of our hospitals and wards. No unnecessary stocks in refrigerators kept. So these are the pictures of some refrigerators. You can see refrigerator drug chart list is there. These are supervised daily and marked also daily. So this is something, another refrigerator. You can see the stars, different color of labels, and how they are managing and regularizing the refrigerators. So then we are using this LASA and high alert medication warnings also in the ward level. So high alert medications, name list displayed. Red color labels are used, stored under lock and key. And LASA drugs also, sometimes we have kept separately, and if we are keeping the drugs with all the other drugs, we have labeled in different ways. Tall and short letters are used in labels with different colors. So this is one of the way. You can see the colors are different. We have labeled in different ways. And then red color labels are used for high alert medicines. You can see here the high alert medicines are labeled, and also these stars are mentioning the expiry dates. So high alert medications are kept under lock and key. So LASA drugs can be easily identified here. They have put these stars in the pairing bottles where the LASA medications are kept. So this is also in the drug cupboards. The instructions are given. You can see the expiry and how the medicines are kept in the cupboards. So labels visible in the cupboards. So always we use visual control method as our wards are so crowded, and for confusions these things are important. So this you can see the different color codes we have used, different colors in the labeling. Here the carbamazepine and carbamazole, there is the different colors you can see. And when the same drug with different dose strengths, we have put this kind of warnings, signs, and by that we can prevent. And these traffic light systems, these are the refilling levels. For different drugs, they have different refilling levels. So we are managing for each drug bottles refilling levels as well. So this is also the same thing. Some other initiatives we have taken, externally using drugs we keep separately, especially the dermatology wards, eye and ENT preparations, we are keeping ahead separately from the oral and injections. So cleaning agents and other things are also stocked separately. This is how we have kept lotions in one ward. And we are defining allergies, and allergy bands are used in our wards. So allergies documented on first page of BHTs and also in the drug charts. Number of antibiotics days given in clearly shown in drug charts. If it exceeds more than 10 days, we always refer with the microbiologist. So these are the drug allergy bands. This is the drug charts, allergies are mentioned. So we have another things like adrenaline pack, always it's with the injection trolley. We use color code for burette sets if we use more than one time, because sometimes when the out of stock, we have to use burette sets for more than one time. So to prevent it, the more hours, we use these color codes and use syringe pumps with appropriate color code. Emergency trolley is managed, supervised daily, and use a proper adverse event reporting system which is introduced by the Quality Secretariat. So this is how we utilizing a color-coded labeling method to enhance medication safety. This is how the implementing color-coded identification system for high alert IV infusions using the color sticking tapes and patient tag system. And this is how we use these burettes to minimize it is more, less than 72 hours. This is the emergency trolley checklist. This is daily marked and supervised daily. This is drug trolley emergency tray checklist. This is the adrenaline pact developed in the hospital and used in each and every ward with the injection trolley. So we conduct the training sessions for the staff members. So for the sustainability, we believe we need established productivity and quality culture and the structure in a hospital to improve this medication safety initiatives in a hospital. So we have a productivity and quality steering committee, and also we have a clinical standard improvement steering committee with the clinicians, and also medication safety committee. In all the units and the wards, we have work improvement teams. They are quality leaders, and we have appointed for each and every work improvement team a medication safety officer. So the medication safety officer and the leaders of the WIT teams can liaise with the medication safety pharmacist in the hospital who is working with the quality management unit to take the necessary initiatives and the implementations in the hospital. And I believe strong leadership. Okay, finish. Strong leadership in every levels is needed, including the clinical leadership. And training is needed, evaluation and rewarding needed. We have done evaluation inter-unit competition on medication safety and rewarded the wards. So this is how we rewarded. DG and all presented, Dr. Galapatti presented. So thank you very much for your patience listening. Sorry for taking 2-3 minutes more.
Thank you very much for that very practical and interesting lecture. Next, I welcome Dr. Upuli Vijaymanna, the Director, Organization Development, Management Development and Planning from the Ministry of Health. She's a board-certified specialist in medical administration from the University of Colombo. Over to you.
Thank you very much for the introduction. Madam President, Professor Galapati, and the Secretary, SLCAPT, thanks a lot for giving me this opportunity. This is about the challenges of implementation of medication safety practices at the national level in Sri Lanka. This is the outline of the presentation and the background. Let us look into the background of the situation. Unsafe medication practices pose a great risk to patients, and medication errors are the leading causes of preventable harm. In most of the times, we had practiced in Sri Lanka 5 rights of medication use. Since many years, we are using these practices: the right patient, right drug, right time, right dose, and right route. These are considered as standards for safe medication practices even in Sri Lanka. But many errors, even sentinel events, have occurred even after verifying these 5 rights by the healthcare professionals. How does this happen? Let me ask a question. How does a pharmacist identify the right patient when the patient's name and medications prescribed in the bedhead ticket are not clear and the doctor's signature is illegible? Errors can happen when no adequate systems are in place. That is the answer. Most importantly, most of the errors are preventable. Many other medication safety activities were introduced in the year 2021 with the preparation of action plan on medication safety based on the WHO theme, medication without harm. One of the previous speakers spoke about this. And there they were discussing about 4 main strands. One is systems and practices, healthcare persons, medicines, and patients. With 3 flagship areas: medication safety in polypharmacy, high-risk situations, and transitions of care. Considering all these action plans, experts in the field had identified 8 components of practice package. So these are the 8 components: implementing error prevention strategies for high alert medications, and also for LASA, look-alike, sound-alike medicines, and also for error-prone abbreviations, and also dispensing labels in local language and using pictograms, patient information leaflets for high alert medications, safe practices with polypharmacy, medication reconciliation, reporting medication incidents or errors. With the introduction of quality and safety concepts in Sri Lanka, some of the mentioned components of practice package were implemented in many hospitals since many years across the healthcare institutions. Keeping that assumption in the mind, a study was done to identify the challenges of implementing the components of medication safety practice package at national level in Sri Lanka. The methodology was study setting was all the teaching hospitals, district general hospitals, base hospitals, and divisional hospitals. Did only key informal interviews with relevant staff categories, including heads of the institutions, doctors, pharmacists, nurses, and quality unit staff. We developed a questionnaire focusing on the 8 components of practice package. So these are the findings, challenges of each component. I'll be talking that later. Okay, so these are the thematically analyzed and the common challenges we came across. No consistency in implementation of various practices in different categories of hospitals, and also within the similar category, some various practices were introduced related to this practice package. Then inadequate interest shown by the relevant staff due to heavy workload and burnout. No assigned person to carry out medication safety activities. So this is a common situation in the country in most of the hospitals. Then insufficient monitoring of the practices by heads of the institution, clinicians, pharmacists, or by any other person in the board. And non-availability of LASA list, high alert medication list, and error-prone abbreviations, and then there's no guidance how to use those. The limited use of local language labels and limited use of pictograms. Then insufficient awareness training and inadequate patient education materials. In no forum, medication errors are discussed. There are many forums in the hospital: management committee meeting, infection prevention and control, drug and therapeutic committee meeting, but errors are not discussed in these meetings. Then basic infrastructure issues such as inadequate space for drug storage, no facilities to maintain temperature, etc., were also found. Then unique challenges in rural areas such as patient education levels and adherence to prescribed therapies were seen. Most importantly, there's no chance of learning from experience and to avoid similar harm happening due to underreporting of medication errors and adverse drug reactions. But if it is in the newspaper, when the newspaper reporter reports, we get to know certain incidences. So this is the situation in the country. Here I'm sharing some statistics of adverse events of the line ministry institutions in the country. Over the years, you can see how much they have been reported. It's a very low, minimum number, low number of reports. In the year 2023, initially it was drugs, IV, blood issues were reported together. Then later the form was revised, and then IV and drug issues were taken later. It was only 877 were reported related to medication errors. So this is a comparison with line ministry and provincial. This was done in the year 2023. The provincial situation is IV and drug issues, only 142 were reported. Now you can see the institution summary as of 31st December 2023, where there are about 60 line ministry institutions in the country and 1,104 provincial institutions, altogether making 1,164, but the reporting was so less. Then let me come out with the recommendations and way forward as being in the Directorate of Healthcare Quality and Safety. The measures, those who are implemented on different occasions, should be implemented as a medication safety practice package with considerable awareness and training of healthcare professionals. Introduction of few changes to the reporting form was already done, and it is filled in two steps. One is the initial part was filled by the reporter, and the next part by the quality management unit. This is a strategy used to promote reporting. And also high alert medication list and look-alike, sound-alike medication list, already prepared collaboratively with the pharmacology department, and thanks for initiating all this. So now we are about to release these lists, and because we are waiting to prepare a guidance for using these lists. Then labeling medicines in 3 languages, in addition to English, Sinhala and Tamil, and also pictograms of the time of taking medicines. Then all these should be ready to implement. Very soon we'll be releasing those. Then also there was a suggestion came from some of the participants to provide printed labels and education leaflets through SPC or MSD so that they can have a unique method by all the healthcare institutions in the country. Then also, with regard to drug and therapeutic committee meeting, at least by sending a circular to make it as an agenda item to discuss about the medication errors. This is also a suggestion. Then about polypharmacy, avoid practicing polypharmacy. So at least for excessive polypharmacy, not to exceed more than 10 medications. I think it is also more, but however. So that this also is a suggestion. And then also, we recently released a circular to appoint a licensed pharmacist to the quality management unit to carry out medication safety activities. Not that she's throughout attached to the quality management unit. She or he will be part-time managing these activities in the ward and supporting the hospital. Then continuous training and awareness programs of all stakeholders and encouragement of staff to adhere to the circulars, protocols, and guidelines. and also regular clinical audits and feedback. We know in clinical audits what we do is we are assessing the current practice against the standard practice. So if we are finding a gap, we need to provide suggestions, improvement strategies to fill the gap. That is how we can improve errors and improve medication safety. Then various measures to strengthen reporting systems. There are many measures that has to be taken by the Ministry of Health and also at the institutional level. Most importantly, patient engagement. We all know most of the errors can be minimized if we can get engaged with the patients when we are treating the patients. So in conclusion, let me summarize a few cost-effective measures. One is to conduct a drug and therapeutic meeting and to have an agenda item and discuss about the errors, and also to create no blame culture, to have discussions. With both these, we can learn from experience and never to make the same mistake again. And also patient engagement is also not a very difficult thing which we can promote. And conducting clinical audits and finding out the gaps and providing suggestions for improvement. And last message from my side is medication error, a simple mistake which can be lethal. Medication safety is everyone's responsibility, and let us do no harm to any patient. Thank you very much for your attention.
Thank you very much, Dr. Uppuli Vijayamanna, for this very interesting and thought-provoking speech. So we now come to the last speaker for the day, Professor Ian Coombs. He is a professor at the School of Pharmacy, University of Queensland, and Chief Pharmacist, Royal Brisbane Women's Hospital. Professor Ian has worked for 35 years in both NHS and an Australian health system as a clinical pharmacist, practitioner, educator, and researcher, and now as senior manager. His PhD and early research focused on investigation of factors causing prescribing and administration medication errors. He has subsequently developed and evaluated a range of medication safety interventions. So he'll be sharing experiences of medication safety initiatives in Australia. Over to you, Professor.
Ladies and gentlemen, thank you very much for inviting me. I sort of semi-invited myself, but last but not least, and standing between Sri Lankans and a nice curry lunch I know is not a good idea, so you should strap yourselves in. I will happily share my slides so that we can hopefully get to lunch. But look, I think what was interesting by all the previous speakers, we're all talking about the same thing, which is looking at how we can prevent patient harm. And I think the other exciting things I've heard are about collaboration, about a multidisciplinary approach. In Australia, we've had a medication safety agenda for the last 20 years, mainly focusing on both safe medicines, healthcare professionals being appropriately trained and competent and capable, systems I'll talk about, and of course, most importantly, informed patients. We're very lucky that we had a Quality Australian healthcare study. It took 5 years to publish it because a lot of people didn't want to see the results, that we were harming 13% of our patients and 4% of those were sustaining adverse drug events. But we know now that we are spending probably $1.5 billion on medicine harm. We realise that we have 400,000 additional ED admissions, and in the elderly, we're talking about 20 to 25% of patients being admitted. Discharges commonly have discharge medication errors. I'll talk about those, and I think a key focus, particularly for all of us, is the transitions of care on admission to hospital, between the hospital, and on discharge. But I'm going to take a little bit of a deeper dive, particularly into some of the medication communication components. We are lucky we have a national medicine policy, as does Sri Lanka. We have a very powerful therapeutic goods and PBAC, looking at which medicines we purchase, and we have up-to-date and available electronic therapeutic guidelines. Probably the other key thing we have is a very active Safety and Quality Commission, where we've now moved to short notice, 24 hours our hospital has, and the accreditation teams come. And they don't talk to us anymore, they go to the wards. They'll go to every ward and every clinic. And to meet standard 4 for medicine safety, there are a number of key deliverables which I'll talk about. This also happens in primary care and for aged care facilities and community pharmacists. I think what's really interesting, a number of people, particularly having worked in Sri Lanka for 15 years, I'm well aware of the idea of trying to avoid a blame culture, but unfortunately some heads still end up on the stakes. Also, in our hospital, when I started at Princess Alexandra, we had a medication committee, and I realized we had a drawer with about 5,000 incidents. Nobody ever looked at them. Nobody ever analyzed them. We just looked at a graph going up and down and felt we were doing the right thing. I think what's really important is we need to analyze these things. And I was very fortunate for my PhD to have advice from various people, including James Reason, where we applied the accident causation model with permission, and also working with Bryony Dean and Charles Vincent. We analysed 22 incidents which all caused significant harm, undertaken by junior doctors in their first year. A number of them were picked up and were very close near hits. What was particularly interesting is there was a median of 4 factors, between 2 and 8, but they also ranged all the way through the work hours, the workload, the handwritten prescriptions, the culture. But then when we looked at the factors at the ward level, there were busy wards, there were continual interruptions, lacks of supervision, particularly between the senior and the junior medical staff, and a huge assumption that people understood what it meant to anticoagulate somebody, stop somebody's beta blocker, sort out their discharge and restart the medicines after surgery, and by the way, sort out their electrolytes at the same time. And I think that there is very commonly seen a very repetitive task, which is, of course, as we know, the most high-risk intervention. And there's complex patients and also errors in the defences, where the guidelines were confusing and where pharmacists didn't always work. But at the end of the day, we are all human. I made this error the other morning, getting up early to go and do teaching, where I thought I wouldn't disturb my wife, so I brushed my teeth with my shaving foam. We wire errors into our systems at our peril every day of the year. So back to some of the early work we did in our postdoctorate work, looking at junior doctor prescribing, that there were certainly key issues around the decision that is invariably made by the senior doctor, or the assumption on admission that I'm just continuing the GP's medicines, and the juniors who are actually undertaking the communication, be it electronic or handwritten, are not involved with the decision-making of the prescription. That is often made by a senior, and you can read those examples there. Just telling somebody they're nil by mouth, swap their ranitidine to intravenous without reminding them it's the third of the dose in somebody who had an underlying arrhythmia didn't end well. A patient who had, again, had to have bridging heparin, which was misinterpreted as being VT prophylaxis, didn't have their warfarin restarted after a mitral valve replacement. And the message was simply on a pager from the consultant: we need the beds, send the patient home. There was nothing about restarting patients' anticoagulation. Then there's the chart design. So at the time when we did this, everything was paper. But not only was it paper, in my hospital, we had 5 different charts. Every evening, junior doctors went on call and covered every area of the hospital. It was inevitable that somebody was going to make mistakes. Certainly, the person who had to re-expose somebody to a very severe cephalosporin reaction thought their career was over, but happily came back to the incident review team and showed us how if you cut the top off the medicine chart, he'd stick the name and the allergy on one place, but not twice. It's a very good human factor design, and in our national study, reduced the rate of ADR exposures by 50%. The warfarin, where some hospitals and some wards had developed their own separate anticoagulation chart, was okay until the covering doctor didn't realize there was a separate chart for warfarin, thought it had been omitted, and over a bank holiday, a patient understandably ended up with a significant terminal bleed. And then simple things like nurses, they know what times to give medicines, and they can read my pseudo-Latin hieroglyphics. Unfortunately, the patient who received 4 times a day vancomycin didn't appreciate that. So I think the other key thing that came out of a lot of this work and has built upon the national competencies now in Australia is that prescribing was actually made up of 4 key domains. There's information gathering about the patient, the medicines, the history. Then there's the actual clinical decision-making, invariably separated from the junior person who's actually generating the order. And in some hospitals, we also had a system which I've seen in Sri Lanka, where the actual order, like America, is written in the notes, and then another person, sometimes a nurse or another non-clinical person, has to transcribe and interpret that onto a medication chart, which itself may be error-prone. And all we are doing is cascading errors. So the medication system is extremely complex, and we've all seen this multiple times. And again, it's the handovers which cause a multitude of problems. And we know that certainly if we're going to change the system, we need to try and take out the human errors. If you go back to the bathroom, the ladies would appreciate this because the seat stays down if you chain it down. You have to make it harder for people to do the wrong thing and support them to do the right thing. So we were very fortunate that our health ministers, 20 years ago in Australia, admittedly, also were getting a lot of pressure about the need for improving patient safety, and they agreed that they should have a national medicine chart. And we developed that based on the human factor research we'd undertaken on our errors and the failure modes analysis. We also then added in a number of key components, particularly areas such as the need for having the medication history documented, which was invariably in a busy junior doctor's history was to take and continue medicines as charted, but then you never knew what had been started, stopped, changed, withheld, or put back on. So the actual medicine history section went on to the front of the National Inpatient Med Chart. They had stat doses as well, and certain high-risk medicines such as warfarin and now VTE prophylaxis, this is changed to all anticoagulants, are included in the chart. The dose times were also put in, and the actual prescribers inputted the dose times. Did it make a difference? Did it take out all the errors? No. Did you still have handwriting? Yes. But when we actually showed in 20 different sites in 5 states, not the states where we'd done the original work, but we actually reduced overall error rate by 30%, 50% of patients reduced ADR exposure, and there was a non-significant reduction in duplication. But the biggest important thing was we had one system that all the students got to see all the way through medical, nursing, and pharmacy school, so they could actually be trained to use the system at the same time. Electronic prescribing has been in place in intensive care units and in some cancer care units for up to 20 years in Australia with degree of decision support, but it's also often been implemented to a point and then not completely implemented. And we've actually been involved with 2 systems that have been withdrawn in local hospitals in Queensland where I work because they actually introduced a whole set of errors that we never anticipated. And invariably it's because they didn't either follow the patient from admission through to discharge or they actually themselves had inherent systems. But Joanna Westbrook's probably one of the people who's done some of the best investigation into 2 different systems in Sydney hospitals. And as consistently as you'd expect, shown that the process errors significantly improved, but without the appropriate decision support almost leading to the artificial intelligence that we've heard about today, it doesn't always lead to a significant clinical improvement. So I think the other key thing is Australia, like a lot of people, and it's nice to see in Sri Lanka, have had a focus on the high-risk pincher medicines, particularly focusing on reducing distribution and dispensing and administration errors. And that includes chemotherapy, anticoagulation, antibiotics, narcotics, insulin, and potassium. We all had the experience of the sort of ampules that ended up in the wrong bin that unfortunately got bolused. And on the 5th occasion where a patient had inadvertently been bolused potassium, we had a widespread introduction of pre-made infusions, which obviously is something many developed countries are familiar with and may have a small cost additional to the product, but the reduction in nursing time in actually having to add the electrolytes, etc., and also the safety is significant. Add into that the safety devices, which is nice to see in Colombo South Hospital and elsewhere, and then the ability for the electronic safety infusions to talk to the prescribing systems takes out much of the human error. But just to go back to the workforce, I think one of the important points is to remember, however many electronic systems we put in there, they're only as good as the humans that input. And thankfully, healthcare will still have our workforce humans. So one of the nice things that came out of having a standard med chart is we could develop a standard safe prescribing curriculum which has been used throughout the Queensland hospitals and still is to this day for over 20-odd years. But it focused on introducing human error, history taking and confirmation, high-risk medicines, and is all based on simulation and is based on error-formed and error-inducing situations and scenarios to almost try and trip people up, but in a safe environment which involves feedback. The competency frameworks have been reviewed again, but it's still very much focused on the 4 pillars of gathering information, making decisions, communicating, and reviewing it, but with a patient at the center of it all. Something else that people have talked about is the importance of feedback in the workplace. And I think one of the things that is extremely important to remember is that our continual pressure on junior staff to both work and learn means that there's a point where you can try and think that people can take on so much knowledge, but feedback in practice is really important. And what this is a midterm, 5-week of a 10-week term evaluation of their prescribing, the blue card in each one. So these are interns in term 1, 2, 3, and 4, and 5 of their first year. Every single cohort with individual feedback of a minimum of 50 orders undertaken by a pharmacist or a clinical pharmacologist had a significant reduction. It works for nurses, it works for pharmacists, and what we'd like to see is the role of the clinical pharmacist as well has been built in there, which is actually probably best to be assimilated with Kumasama Kakara, your excellent wicket-keeper. The key focus is around also the reconciliation and the bundle, which itself reduces unplanned readmission, and that's a correlation of 4 key things: history, reconciliation, education, and discharge, which even in a hospital with electronic prescribing significantly reduces safety. I'll leave you with that summary slide, ladies and gentlemen, but it's been exciting to listen to all the work from around the world and also what's happening in Sri Lanka. Happy to talk to people over lunch. Cheerio.
Professor Coombs, for that very enlightening talk on what's happening regarding medication practices in Australia. Unfortunately, due to constraints of time, we will not be able to take any questions.
So that brings us to the end of this panel discussion. So I take this opportunity to thank all our eminent speakers for their excellent and thought-provoking speeches that makes us realize the situation with medication safety in the country as well as the way forward. And there are some very important take-home messages also after listening to all the speakers. And so as the last task, I would like to invite all the resource persons to come to the stage to receive their certificates of appreciation from our co-chair. Dr. Chiranthi Liyanage. Dr. Lauren Walker. Dr. Sagari Kiriwandeniya. Dr. Uppuli Vijayamanna. Professor Ian Coombs.
Thank you very much for that comprehensive session. Ladies and gentlemen, let's break for lunch now. Lunch is served downstairs at the Cinema Lounge. Please make sure to return promptly by 2:15 p.m. for the next session. I would like to take this opportunity to remind participants from the Ministry of Health and those needing CPD certificates to make sure you have signed the attendance register to receive CPD certificates. Please ensure you register today in addition to yesterday so you can receive the full 10 CPD points. Thank you. Enjoy your lunch.